Ooh, you all got quiet for me. I didn't even have to ask. Excellent. Okay, well, buenas tardes, React Alicante. Yes, I'm excited to be here. I saw some of the videos from last year's conference, and some of the talks were so awesome that I was like, man, I got to try to make my way all the way to Spain. And now I'm here, so I'm so excited. It's my first time ever in Spain, and I've been learning Spanish the last 4 or 5 months, and I got to actually use some of my Spanish. I will not be using any of it in front of you all. I'm not trying to embarrass myself, but I have talked with a number of my coworkers in Spanish, and they actually understood what I was saying, and I understood what they were saying, so my teacher is actually pretty good. And also had a great time yesterday, had a React and Redux testing workshop yesterday, which was a lot of fun. But I'm going to be talking about something completely different today, okay? But first, let me thank our sponsors like everybody else has, and I want to call out a specific sponsor that's listed up there, and that's Eventbrite. We sponsored the lunch, which was really good. I got to taste paella, which was really wonderful. I wanted to brag about the fact that we were sponsoring the Wi-Fi. But the Wi-Fi is not that good, so we'll just take credit for the lunch, okay? So that's the deal. So now the purpose of my talk. Last year I was in Portland, Oregon, in the United States. I was at a conference called Chain React with Gant, who spoke earlier about testing. There's Gant way in the back. And it was a React Native conference, and I was speaking about React Native and ES Next, or the future of JavaScript. And I got plenty of questions after my talk about it, about ES Next, about React Native. But I did have one person come up to me after the talk and pull open their laptop and ask me to help them debug why their app was slow. This app that I had never seen before, had no context, and was like, hey, do you have any ideas about this? You were on stage, so you must know something, right? So, I try to look at it and try to debug some things and try to point it out. I don't know how much I was able to help them right on the spot, but I did try to give them some pointers. And then 2 days later, I returned home to San Francisco, the Bay Area, in California, and I went to a React meetup in SF, and Trey Huffing had a whole talk about React performance. So those two experiences, plus the experience I've had code reviewing code at Eventbrite, were kind of the genesis for this talk. So the slides for this talk will be like automatically tweeted out. I planned for it to be tweeted out when my talk started, but I started 10 minutes early, so it'll be there in a couple of minutes. But I also have the link here at the bottom left if you want to follow along in those slides. So first, I want to talk about something called reconciliation. So internally, React uses several very clever techniques to minimize the number of times we have to update the DOM. And that's how we can write our code such that it looks like every time something changes, we're completely rewriting the DOM, but we're actually not doing that. The reconciler makes that possible. So it keeps a copy of the render tree before, and then creates the new render tree afterwards, and then does a diff to see what has changed, and only updates the things that have changed. So for most apps, using React will actually result in a faster user interface. You don't have to do any kind of special optimizations for performance. But as we know, it's not a silver bullet. And there are a number of ways that you can write your code, that you can change your code in order to speed up your React app. So if you have noticed a slowdown in your app, you might want to take a look at some of the things that I'm going to talk about, and they could help make your app faster. Or if you're in a situation where you have something that needs to be really high performant and you need to squeeze out every ounce of performance, then these could help as well. So, but before we get into this, I would like everyone to stand up with me, like everyone to stand up. So, we're all pretty tired, right? And it's been a long day. And I like to exercise not only your brain, but also your body, okay? So what we're going to do is we're going to do 10 squats. Yeah, we're going to do 10 squats just like that, okay? So, and since we're in Spain, I thought we could count and count by Spanish. So I will do some Spanish. I do know how to count by 10 without having to think, okay? So let's do it all together. Here we go. Ready? Uno, yeah. Dos, you got to count too. Come on. Tres, yeah. Cuatro, cinco, keep going. Seis, almost there. Feel it. Siete, ocho, nueve, and 10. Great job, everyone. Nicely done. Nicely done. Nicely done. Woo. Okay. We've got that blood flowing. Great. Okay. So now I just wanted to formally introduce myself. So my name is Ben ILEGBODU. I'm a Christian, a husband, and a father. That's my wife, Rashida, on the far right. We've been married 8 years. We actually celebrated our 8-year anniversary last week when we were here in Spain, so that was pretty nice. And we have 2 daughters. Simone's the one next to me. She's 4.5 years old. And Avery there, she's 2 years old. She celebrated her 2-year birthday at the beginning of September. And if you've happened to see my wife walking around, my whole family's here with me. She's actually pregnant, so we're expecting our 3rd child in the middle of January. So thank you. Thank you very much. So we live in, like I said, in the San Francisco Bay Area in a small town called Pittsburgh. If you're familiar with the United States, there's a Pittsburgh, Pennsylvania with an H at the end. I live in Pittsburgh, California without the H, so it's completely confusing, but it's okay. So yes, I work for Eventbrite, and we have offices all over the country, all over the globe, I should say. And we recently added a company from Spain called Ticketea to the family. Yeah, a number of them are sitting back there. Some of them are wearing Eventbrite t-shirts. Others didn't get the memo, but that's okay. We have an office in Madrid and as well as an office in Vienna. So not Vienna, Austria, but Vienna is what they tried to convince me how to pronounce it. Was that good enough? Vienna. So if you're interested in Eventbrite and what we do, we're certainly hiring in this area. So please go out to our booth out there and talk to Carlos. So just a little bit more, I'm a principal front-end engineer at Eventbrite in our SF office. Our team, front-end platform, focuses on our front-end infrastructure, so a lot of the tooling that we were just hearing about before, and then a lot of design systems that you heard earlier as well. That's what we work on. So enough about me, let's talk about React performance. So I've broken this down into 3 main sections of things we want to try to avoid to help our React applications be more performant and run faster. And I've tried to order them by things that are most hurtful to the least hurtful, and I'll try to provide alternatives and fixes for those things. So first, we want to avoid unnecessary DOM updates because touching the DOM is the most expensive thing that we can do. And first, we're going to talk about the impact of the key prop or the key attribute when you have an array of React elements. So here is an animation of an app. It's a simple app that has a list. And you click the add button, and when you click the add button, it adds something to the top of the list. And as you can see on the right-hand side, when I add something to the top of the list, all of the elements in the list update, even though all I'm wanting to do is add something to the top. So in our mind, we know that really all we need to be able to do is just add something to the top. Why does the whole thing update? And the reason for that is by the way that we sometimes write our code. And that's if we use index as key. So here we have the code, we're looping over an array of data, and we're generating li tags, and we're using the index as the key. So what React does is it uses the key to associate elements before and after renders. So when it sees key 0, and it's comparing the next key 0. So when I add something to the top of the list, what was formerly key 0 is now key 1. And what was formerly key 1 is now key 2. So what was 0 before is now 1, and the new 1 and the old 1 are not the same data. So it thinks, oh, I need to touch the DOM and update it. And it goes down and down and down. And then what actually happens is that it adds a new element to the bottom, which was the previous last one. So that's a problem because we're touching the DOM way too much. So what we should do instead is use a unique value as the key instead of the index as the key. So index as the key is definitely easier, but unique value is more performant. So we actually have to find a unique identifier that we can use as the key. That way, as you're adding elements to your array, or putting them in the middle, putting them at the end, putting them at the bottom, the key stays constant before and after rendering. So then now React knows how to associate things and make it more optimized. So the value you use as the key can be an ID from your API, it could be a timestamp. It just has to be something unique. And it only has to be unique in the context of the array. It doesn't have to be globally unique across your entire React application, just unique in terms of the items in that list. So the result of you doing that now is that when you add something to the top of the list, all it does is just update the first one, which is kind of what we think is what should happen. And it saves a lot of unnecessary DOM manipulations, which I said are the slowest things we can do. So for this app, you totally won't notice, right, the difference between index as key and unique value as key, and maybe for some things that you do, you won't notice it as well. But as your app gets bigger and bigger, and as you have more and more data, that can have a really big impact. So that was one. Let's look at number 2, and that's HOCs, or higher order components, and the impact of using those inside of your render. So HOCs are a way to share UI logic across components. So you end up wrapping your component in an HOC, and it provides enhanced functionality, basically. So there are many ways to do this kind of sharing of functionality. Actually, Forbes will be talking about another way using render props tomorrow, so I highly suggest that you come and listen to that, because they are actually a newer way of solving this problem. But HOCs are what are really popular right now. So let's say we had an HOC called with title, like I have here, and what it will do is it enhances our component by now accepting a prop called a label, and then it'll take that label and put it in a label tag, and also wrap our component in a div. So actually what this does doesn't really matter. I just wanted to explain it a little bit. But how it is used is what really, really matters. So a naive use of HOC would be to put it inside of the render here. And this will work fine. The UI will display correctly, but it actually has really, really, really big consequences. See, what's happening is that every time render is called, for whatever reason, it's creating a new component each time. So every time emails is getting re-rendered, we're creating a new component type. So even though they have the same name, it's an entirely different component from the last time. And the result is that on every render, the previous list with title, the one that we enhanced, is different than the new one that's just rendered. So what happens is that the previous list with title gets unmounted from the DOM, completely removed, all of the event handlers, all of the UI gets removed, and now a new one gets created. So we're completely destroying that DOM and recreating that DOM over and over again, even if the component is the exact same. So this actually might be worse than the key situation because we're blowing away the whole UI each and every time we're rendering. So once again, in a small app, you may not notice this, it may not be a problem, but the bigger your app gets, the bigger the list with title component is, you can see the flashing happening. So the fix is actually really, really simple. You just move the creation of the enhanced component outside of the render, outside of the class at the top, and you define it once so that now its value, the component type is the same with every render, and now it's only if the props change that the DOM has to update. So now we're going to be able to benefit and leverage reconciliation. Okay. But speaking of reconciliation, so reconciliation, like I said, is React going down the entire component hierarchy and calling render on everything. And then it checks, has anything changed, and then updates the DOM if necessary. But even if there's no DOM changing that needs to happen, the reconciliation calculation to determine before and after could be costly for large apps, especially when nothing changes. So after we've done the work to avoid unnecessary DOM updates, we need to now work to avoid unnecessary reconciliation. So we're getting to the point where we're doing micro optimizations at this point. So most of the time, you shouldn't need this, and I would suggest probably not developing these in the beginning, but taking a stock of your app and then maybe adding them after the fact if you feel like you really need to make these changes. So the first thing I want to look at is should component update and the impact of it. So should component update allows finer grained control about when reconciliation should happen. So this is the default of what React.component gives you for should component update. It just always says true. Always do reconciliation no matter what, and we'll rely on whether there was any differences to update the DOM. So even if the props and the state are the exact same before and after, it will still go and do all the reconciliation. And reconciliation usually is fast enough that it doesn't even matter and we don't even notice. But if you find that there's some situations where you really want to prevent reconciliation, you really need to not have that whole calculation happen, there's ways that you can tell or give a hint to React not to do the reconciliation. And essentially you want to return false in a certain situation to skip or to give it a hint to skip render. So in this example, we will render only if the next props doesn't shallow equal the previous props, or the next state doesn't shallow equal the previous state. So basically, if anything changes, if the props change, if the if the state changes, we will render. So this works as long as you don't actually mutate your objects in their props and state. So if you want to add something to your state, change something to your state, you actually make a copy of your data so that it's actually a different reference than what it was before. And that way, they don't shallow equal each other. But there's really no point in actually writing that code because this is exactly what React.pure component gives you. So it's a flavor of component that already does the shallow equal comparisons for you. So if you're mutating your data in a pure way by making copies, you can just leverage pure component instead. So that's a fix for preventing should component did update. But I just wanted to give you an FYI, the stateless function components that you write are actually like a React.pure component. They're not pure component. So that means that reconciliation is always happening down the tree. Not a bad thing, just letting you know that it hasn't been optimized as you may think. Even though it's called like a pure function or stateless function, pure stateless function, all those adjectives that happen, it works like React.component. Okay, 3 down, and we have 5 more to go, but let's look at shallow comparison since we just were talking about that. And let's look at the impact of accidentally negating the shallow comparison that we want to use with pure component. So you may be thinking, hey, I'll just make everything faster by search and replacing React.component with React.pure component. And I'm going to get like a 3x speed up. There's some things to consider, okay? So let's take a look. Things that we may unintentionally do to break shallow comparison. So creating an array, a new array literals or object literals on every render is cheap. Like the garbage collection is fine, like that's not a problem. However, in this example, if data table is a pure component, props.page sizes won't shallow compare to next props.page sizes because we're passing it an array literal. Even though their arrays are the exact same, 5, 10, 25, 50, they're actually, each new array literal is different, so they won't compare, and reconciliation will happen. Even though it didn't need to because the data obviously didn't change, and it's the same for footer info as well. So what we should do, pretty simple, just make those a const. Pull those outside of the class, and then now the references are going to be the same each and every time. So it's passing the exact same value for page sizes and for footer info each and every renderer. So now props.pagesize does shallow compare to next props.page sizes. So that's one way that we undo it. Another way that we undo it is with functions. And this is a very common one, and is actually something that's very common in my code and in our code within Eventbrite, is inline arrow functions or calling .bind in order to pass the this context. So the problem is that with every render, they create a new reference of the function, so that they have the this scope. But props.onDelete won't shallow compare with next props.onDelete because it's a new function each time, and even though the function is not changing in any way, it's really the same type of function. We just need the new this in the scope. So people always say that the problem with this is, oh, you're creating a new function every time. You're throwing away all these functions. That's so slow. And really, I don't believe that's the non-performing part. The bigger issue is undoing pure components shallow comparison. Because now doing the shallow comparison fails, and we're doing the reconciliation unnecessarily, and all this code is happening. So there are actually 2 ways that we can fix this. There's like the old way and a kind of newer way to fix this, so that we can only bind the this one time. So you can do it in the constructor, and you can basically override the method handle select with a bound function handle select that has the this scope inside of it. So we're basically overriding, it doesn't really seem like it, but we're overriding the method with a function property in the constructor. I'm not a fan, but like I said, this was very prevalent when ES6 classes first came out in React that way. The alternative way is to use stage 3 JavaScript functionality. So future JavaScript, which is probably coming out in 2019, most likely, but we probably are already leveraging it now because of Babel and transpilation. So what it does is it basically, instead of having a method, it just has a property function that is an arrow function, so it has the proper this. So the nice part is that in the use, in data table for onSelect and onDelete, we no longer have to dot bind this. We're passing the same reference each and every time, and the shallow comparison will be the exact same. Props.onDelete will shallow compare to next props.onDelete. Okay, so the last thing that we do to mess up shallow comparison is derived values, derived arrays, derived objects inside of render. And those are inherently new objects each and every time, even if the derivation is the exact same. So in this example, we're filtering items in props and query from state to create new items. So even if new items is the exact same, because props.items and state.query haven't changed, new items won't shallow compare with next props new items. And there's no real simple fix for this, unfortunately. You can do some caching of the data on the object and such, but it gets kind of gnarly. You may consider making list in this component, the list component, do a deep comparison instead of a shallow comparison. So overriding a component did update to do a deep comparison. But it's likely that that deep comparison calculation would take longer than the reconciliation itself, because the reconciliation is so good that it may not be worth it. It just kind of depends on your list and what it's doing, how long the list is, to determine if that's the best course. Okay, so 4 things. The 5th thing is the impact of having a super huge render function, okay? So I don't know if you can see this in the back, but that was kind of the intent. So let's say you have this big component that has like hundreds and hundreds of markup, lines of markup in the render. So it's already bad for readability, like nobody can code review this, like no one knows where in the render things are, but let's pretend like not you, but someone next to you wrote this code, okay? Right? Someone who was not at this conference. So if the search form component here triggers a change with its onChange prop and updates the state, and setState gets called, all of the render will happen again, right? And we'll re-render all of that markup again. So of course, reconciliation will kick in and it will figure out that the DOM didn't change and not touch the DOM, but it's still like a whole bunch of stuff that has to be resolved. It's like hundreds and hundreds of lines of DOM. There's like no component boundaries to even have a pure component to have that shallow comparison do the check to prevent reconciliation. So by componentizing our markup, we create what are called like component boundaries, and they can implement pure component to stop reconciliation when the props don't change. So it's already beneficial to componentize your markup because for readability, but it also helps performance as well. So now the nav component, the data table component, the pagination component, they can all avoid reconciliation if their props don't change, which will be really nice. And you don't even have to put your components in a different file. You can put them all at the top of the file as functional components, so at least they're all there, still in the same place, and you don't have to go hunting around for components. It just makes sense for readability. It makes sense for performance as well. Cool. Okay. So now we're leaving the React world and we're going into Redux world and fixes that we can do for performance there. How many people in their React apps are also using Redux? Yeah? Majority of the folks? Yep. So hopefully this will ring home and could help you as well. So in a React application, having multiple set state calls is not a problem like we have here. So we're setting state on selected ID and also on color. And that's because set state is asynchronous. So even if you call it multiple times in a row, what will actually happen is that it will just merge that whole object together, and that's actually what gets updated and what actually gets passed in to render. So we're kind of safe in that regard. It causes, set state being asynchronous causes other bugs for us that we've probably run into, but in this case, it actually helps with performance. However, if we do the same thing with Redux's dispatch calls, we can run into problems. So let's say you're using something like Redux Thunk for your asynchronous actions. That's what we use at Eventbrite. And you need to update 2 parts of your Redux store, okay? So you may already have like existing actions that update those 2 parts of the store, and now you have this new action that maybe makes an API call, and then as the result needs to call those 2 actions. So here the dummy actions are set selected and set colors. And you could just call them directly one after another, because I need to set the selected ID, and then I need to set the color to blue, because that should be your favorite color. It's my favorite color. So the problem is that you have those 2 reducers that are mapping to those 2 actions that are responsible for the state here. So the selected ID state and the color state. The problem is that this ends up resulting in 2 render calls for every for the 2 dispatch calls. So every connected component, everyone that has connect around it, is going to render twice. The first one is going to be the one for a selected ID. When that gets updated, it's going to render out, and then the next one generates when the new state of the color is updated. We're going to render again. And the problem is that first render for the selected ID, you would never really see it. The eye was not able to perceive that render, but you'll be able to feel that it's sluggish because you had that dual render happening. And as you have more components that are connected, bigger components that are connected, the problem just will exacerbate and get worse. So instead, what we should do is just to create a single action that passes all the data that'll be needed for those reducers. So here we just have a mark unread action, because that's what the action was, and then we'll set the payload needed for both set selected and set color. And if needed, you can do some helper functions so that you're not writing the same code over again, but the idea is that you pass that action. So then what happens in your reducer is that they both listen to the same action type, right? But they pull off different pieces of the payload in order to get the data that they need. And the result is that you just have one render because there was only one dispatch. And you have that optimization there for you. Okay, so now we've avoided the DOM updating. That was the worst thing. We've avoided reconciliation, which really isn't that bad, but can be bad if you have really big components. Now we're just like avoiding calculations or avoiding JavaScript at this point. Like trying to write, just not trying to execute code that we don't need to. So really, this part probably won't matter unless you're like creating some kind of DNA design tool or a rich text editor or like a full spreadsheet, like you're recreating Google Sheets for some reason. Like anything that has crazy data requirements. I remember someone was talking earlier about something with like 200 forms in it. Like maybe then that would be a problem. That's what Eric was talking about. But the reasons you may need to do this is like if the calculations for the code to determine whether or not to prevent reconciliation, so the prevention code is too complex, you may need to change your code, but then you might as well just let reconciliation happen. More likely it could be because the code that you need to calculate the new state from the old state is too complex, and we need to make that more optimized. And that's what I'm really going to focus on. So the first one is the impact of copying objects and arrays to avoid mutations. Because like I said earlier, that's the way we keep things pure, right? We copy objects, we copy arrays, and then we make the change to that copy. So copying a large array or an object can be expensive. And we copy, like I said, to enable pure components. If the data changes, we create the new object, and then we mutate that. So here's a reducer for a dummy email app that I actually use in my React workshop. And first, what it does is to delete an email, we use .filter, which is actually a pretty cool algorithm to delete something from an array that I found. So we keep an email as long as it doesn't match an ID of the payload. And as we learned, using filter creates a new array, a shallow copy of the array, rather. So if this array is huge, then this filter is going to take some time. Second, to add an email to the beginning of the array, we use the spread operator. And this also makes a copy and then puts the thing in the front. So again, if the array is huge, this will take some time. And then last, to update an email in the array, we use map. This also makes a copy. But then also, to update the actual email, we use the spread operator for objects, and that also makes a copy for the object. So again, if the list of emails is long, if the data for the email is big, this will take some time. So to reemphasize, copying an arrays, copying objects usually isn't a big deal. So I don't want you just like jumping to this solution from the beginning, but for a large amount of data, you may want to move into having immutable data structures. JavaScript doesn't have immutable data structures by default, but you could use something like immutable JS or seamless immutable to have true immutable objects. So immutable is the big player. It was created by Facebook. I've only used it a little bit. I found the API actually to be a little cumbersome because it's very different than the native APIs for arrays and objects. And I constantly found myself going from native arrays or objects to immutable objects because in my React components, I just want to deal with native objects. It's only really in Redux when I'm mutating data and in my reducers that I need to use immutable. So I was going back and forth, which I found pretty annoying. However, seamless immutable is an alternative, and its data structures are backwards compatible to arrays, so you can use them just like arrays and objects, except they won't actually mutate the objects. And it's a lot lighter to use, I found, than immutable. And you can even pass it to libraries like Lodash or underscore, and it'll do all of the data manipulation for you. Okay. The last one, the impact of recomputing Redux derived state. Okay. So here's a traditional connect here from React Redux. And it connects, and what connect does, it subscribes to the Redux stores and causes the connected component to re-render with the new state as props. It's got a map state to props, which calls get visible to-dos, which derives a visible list of to-dos based upon the full list and a filter. So this works great, but one thing to know is that this gets called every time the state tree changes. So even if another piece of state changes somewhere else in the state tree, this code will still get called. The result is that the list would be the exact same because the filter list would be the exact same because the list and the filter didn't change, but it still gets called and derived every time. So the bigger the state tree, the more likely that this unnecessary derivation is going to happen. And then furthermore, like I have highlighted here, if the calculation of get visible to-dos is expensive, like the actual work to figure it out, because we're doing all the copying of arrays like we just talked about in the previous section. We're making unnecessary and expensive calls. And then to make matters even worse, because we're copying, shallow compare will fail even though the data is the same. So the reconciliation will ultimately happen all the way down the component tree, even though we know nothing's happened. So we're basically have 3 compounding errors on top of each other. So what we can do is use something called memoized selectors, which basically means caching the results. So if the inputs don't change, the derivation doesn't change and nothing is recalculated. So we use a function from reselect called createSelector to create a memoized selector. And then it takes an array of input selectors as the first parameter. And getToDos and getVisibleFilter, they are the simple input functions. And they just retrieve stuff off the state, so they don't do anything fancy, no kind of calculations. Then the second parameter to createSelector is the transformation function that actually generates the derived data. And then lastly, getVisibleToDos is called passing the entire state. So it will return the derived state, derived visible to-dos, but will be cached if it was calculated before and nothing's changed. So the benefit of the cache is, 1, it saves on unnecessary calculation. 2, it saves on unnecessary data copying. And then 3, saves on unnecessary reconciliation because the object will be the exact same because it was cached. Okay, so that was a lot. Wanted to give you a quick recap. So like I said, all these things can make your app faster, but don't prematurely optimize. React is already super fast, so just like go build the thing first, and then if it's slow, fix it. But this is a quick TLDR in case you missed anything, in case you fell asleep, because I made you do squats. Okay, so number 1, use unique value as key. So that gives us smarter DOM updates. Create HOCs in the render to prevent unnecessary unmounting and remounting. Use pure component for shallow comparison. Avoid undoing shallow compare by storing an object constant outside or pre-binding your functions. So the values will remain constant across renders. Number 5, break up your components. Mark them into component markup into helper components so that the reconciliation can be prematurely halted. And number 6, combine multiple dispatches into one to prevent multiple state updates. And then number 7 and 8, use immutable data structures to reduce the effects of copying data, and then use memoized selectors to help reduce unnecessary recomputation of derived data. And the TLDR of the TLDR is a list here, so you can have them there. Those are the 8 things that we did together. So that was a lot. I got a lot of more resources for you. Unfortunately, I didn't have time to spend time on how you actually can debug these issues and figure out what's causing issues. The first library that's listed there, React Virtualized, supports what's called the windowing. So if you have a list of 20,000 elements for whatever reason, you can't see all 20,000 at a given time. It will only show what's visible on the screen, and there's a whole bunch of magic to support the scroll bar position and such. But these articles go into a lot of detail about debugging. In the article, I read one of them, I'm not sure which one it is, but it talked about running Chrome 4 times slower than normal to simulate a slower device, and it kind of illuminates more issues that you may not see on our fast MacBooks. But I did want to highlight one thing. So Elijah Manor has an egghead lesson on using the new profiler that was enabled in React 16.5.0 that just released last week. So he was already able to create a video series on doing the debugging. And it generates, it's blank. Okay, sorry. So imagine it generating flame charts for you so that you could see what is showing what's taking too long to render. I have a link there, so just go to that and you will see it there. Okay, so that's basically it. Hopefully 1 or 2 or 8 of these suggestions will prove useful to you. But like I said, don't prematurely optimize. Some of these you can do before building, while you're building. Most of them do afterwards when things become a problem. I would really, really love to hear if any of these actually help improve the performance of your app. So I am Ben MVP at all of the networks. BenMVP.com. You can find me there. I have an AMA that you can reach me on. Tweet me if you found some things. But to close, I wanted to give a couple of shout outs. So I wanted to shout out first the conference for inviting me here all the way from San Francisco to Spain so that I could be here and share my knowledge with you. And also for just putting on this conference. Like, putting on a conference is a whole bunch of hard work. And there have been picking the people and just running it the whole day. It takes a lot of work, and the talks have been great so far. So I wanted you to help me and join me in celebrating Victoria and Nacho and the rest of the team for doing such a great job. Thank you so much for that. Yes. All of the folks in the red shirts, thank you so much for doing this. And then also wanted to thank Eventbrite also for letting me come, right? All the way out here. They're really supportive of me speaking and sharing with folks. And like I said, they sponsored the conference, they sponsored the lunch, they sponsored the Wi-Fi. But we really want to invest in the Alicante region. Like I said, Alicante region. Like we said, we have an office in Vienna. That's really close by. So we see that this is a growing hub of tech. So we want to be a part of it. And if you want to be a part of Eventbrite, come talk to me. Come talk to my coworkers, the ones that are wearing the Eventbrite t-shirts. And we'll tell you some more. And then lastly, wanted to thank all of you, obviously, for attending the conference. I heard last year there was 200 people. This year there's 350 people who are here. So that's amazing. And I go through the stress of preparing these talks, stress of talking in front of all of you, and the hope that you all can learn something from what I was able to share. So if you just learned even one little thing during this whole thing, it makes all of it worth it. So thank you all very much.
Thank you, Ben, for such a great talk. Thanks a lot. Yeah.
So I will take 3 questions.
3 questions, guys. Do you have
I have
questions?
3 Eventbrite water bottles for those who ask questions, okay?
Now you
so
want
hopefully
to
you'll
ask.
be motivated to ask these questions. These are some nice water bottles, okay? But we have to be respectful of the person who's asking the question, please. So if you can keep it down, I'd like to hear it. Hopefully you'd like to hear it. Let's go.
You said when we have an array and we want to render it, let's suppose we have repeat values. So it's a plain array of strings. We cannot choose the ID as the key.
Yep.
Usually what I do is just to create a counter variable and then make it incremental and use it as the key.
Yeah.
Is there any better way to tackle that?
So if you have an array of strings and you really don't have anything that's unique, or it's not a record of data, that's the problem, right? So if the array of strings themselves are unique, then you could use that string as the key, right? So it's always trying to find something that can make it unique. You can concatenate different things in order to make it a unique value. But if all else fails and nothing can be unique, then then you can't do anything but use the index. But really try hard to find the unique value, and it'll help with that. So yes.
Okay, thanks.
Yep. Here you go, 1 water bottle just for you. Okay, I got 2 more, 2 questions.
He was first, and then you. Okay.
Thank you for the talk, Ben.
Yeah, you're welcome.
Do you agree that functional components are faster than regular ones?
Are functional ones faster than the regular ones?
Yeah, or is it a myth?
They are basically the same with the React dot component. So the plan was for the functional ones to like circumvent certain code paths and stuff, but they don't currently yet. So there's no performance difference between them, but there's obviously the code readability difference between them. So yeah.
Okay, and another one.
Ooh, you only get 1 bottle though.
No, one. Yeah.
Okay.
I think you have an error. You have a mistake in your examples. You mutate the state in the reducers. So don't do this.
Okay. So I made a mistake in my code, so that's good. Please let me know what that mistake is, and I'll definitely fix it. Because you shouldn't mutate the state. That's bad. Okay. Do you want this? You want this water bottle?
Yeah.
Okay. Okay.
All right. So first of all, great talk. Second,
Thanks.
good luck with the third kid. I know it's tough. We can talk about that later. But regarding the profiler, especially the new ones and how this is going to be. So we saw the React suspense.
Yeah.
We're all pretty excited about it and all that. But how much do you think is going to change on that optimization code that we have to do after we get suspense? We're going to go full asynchronous now.
That's true.
And all this data shallow comparison basically will not halt the render anymore, and your computer died. Yeah. And so how much do you think that we're going to stop doing?
For sure, yeah. So I think what's going to happen is that the things that we have to change for optimization, or the things we do for optimization, are going to change. I'm not quite sure what those things will be. I know that things like the key, I know the things for touching the DOM will still be useful. The ones around the reconciliation are the ones that are going to be the ones in question, because the way reconciliation is going to happen is obviously different because it's no longer synchronous. So I don't know actually what those will be. Probably by in a couple of months, as we start building these apps and seeing what they look like, these suspense apps, then we'll know. But the nice thing is that they built the profiler into it now, so we'll be able to inspect and see what's actually happening, what's affecting it. So yeah.
Great, thanks.
Yeah, you're welcome. Last bottle. Okay, thank you all very much. I really appreciate it.